back again. Today we're gonna be doing some physics. Uh, it should be pretty basic stuff again. Um, I'm not gonna lie. I would like, although some of the cards were very easy for the equations deck last time. I will say that the reviews have actually been torturous. I don't think it's encoding quite as well as I hoped it would. I feel like maybe knowing the context behind the equations would probably help. And to be honest, that's probably why I want to do physics today. Um, Obviously, kinematics is like one of the easiest things in physics, so it shouldn't be too difficult of a day. But I know that, look, fluids, bro, when I get to fluids, I'm gonna start having some serious trouble. Honestly, I'm gonna have serious trouble as we advance in all the chapters, but um I guess we'll get there when we get there. Um but yeah. I said that we would always start with um we would try to start with we can start with like with the connections. Um so give me 1 second so I could put it on. Uh let's see. All right. Sorry, 1 second. Literally, we just wanna get like we just need to get in the zone. You know what I'm saying? Uh, why isn't the window popping up? If I come over here, maybe. Um, I don't know why it's like shifting the screen around so much. Um, am I blind? I think I might be. I genuinely might be blind. What is going on? Maybe, maybe if I also need. I'm also looking at the wrong account. Uh, all right, here we go. Um, okay, so let's do. All right. Uh, so feel like that might be it. That might be one. Damn, I wasn't even close. All right, bro. I wasn't even one off. Um, we're gonna do. Um, I don't even know. What the solar system attached to, bro? Uh, I just don't know. DNA, atom, solar system. Uh, bro, that's literally it, bro. I'm about to put volcano, bro. Like, bro. What? That was one? Yo, I literally was just clicking random ones. I was like, I don't know, like circles, like circle-ish, like electrons, like circle-ish, like a helix. Like if you look at it from above, it's a circle. Like solar system, it's technically elliptical, but we could go with circle. Volcano at the top, it's also a circle. That's what I was thinking. Um, uh, literally, I feel like that genuinely didn't help me at all. Uh, earthquake, earthquake pills. Iron bird seed and earthquake pills. I just want to put them together. Just like what do those have to do with anything? Um, uh, bombshell, TNT. Tinderbox. Not even a one off, bro. Oh my god. Still not a one off. Bro, I'm doing terrible. This is a hard one. I can't even get the easy one, bro. Bruh. What was it, bruh? Shocker. A thunderbolt. I was close though with that last one, right? Yeah, that was one off. Bro, what in the world? I don't know who that is. Yeah. Yeah, the purple is always such a joke, bro. Okay. All right, let's go back. Let's go back to Anki now. Um, hold up, guys. Not there. Um, all right. Okay. So now we go kinematics, and let's get it. Yesterday, um, I also like suspended some of the cards and equations. I suspended probably like a good like 20 something. Um, so yeah, because they were like either replicas or things that we kind of already learned in the decks themselves. So it's like I'm not gonna do the card twice. And obviously there's still gonna be more. Like I just suspended the ones that I already learned or that I already know. Um, so that's gonna be the reason why maybe some of them don't appear when I'm studying. A scalar is a value that obviously it only has a magnitude, no direction. Yeah. A vector has obviously magnitude and the direction. What does multiplying a vector by a negative number? It flips the direction. Wait, what? What does multiplying the vector by a negative number do? Hold up. Let me run the check on this card, bro. Because what? Yeah. Okay. I like this edit that Gemini basically just made for me. Um. All right. Yeah. I don't know why I would say that it doesn't change the direction. That doesn't make sense. All right. Well, like yes, I know that it's gonna change the magnitude because I mean, like it's gonna change the I thought it was just like a negative number, like -1. Obviously, if you're multiplying by a bigger number, the magnitude is gonna change. I thought that was obvious though, so I'm impressed. I'm gonna click good, even though technically I guess I got it wrong. But describe the tail to tip method. I low-key don't know. I forgot about this. Oh yeah. Used to calculate sums slash subtractions. Put all vectors tail to tip. Flip the vector for negative. How does one break a vector into components? Um, so if you have a vector quantity, you're gonna uh like relative, I think to 0 degrees, like you're gonna multiply it by sine for the y and cosine for the x. Oh, that's not what I thought it was asking. It's a horizontal. I feel like I know this. I'm gonna suspend it. I described the tail to tip method. Um, the tail to tip method is um you put basic literally the name. Like you put the vector, like you're using it for sums or subtractions of vectors. Uh you put one end of the vector on the tail, the other end at the tip. Um and you're gonna flip the direction if one of them is negative. Which component will cosine theta x? How does one calculate the magnitude of a vector from its components? The Pythagorean theorem. How do the components of vectors add when two overall vectors are summed? Um, I'm pretty sure they add directly, bro. I feel like they literally just add directly. They're not like multiplied or anything. Yeah. When multiplying vectors, what type of product should be used to create a scalar? The dot product. What is a dot product? The product of the two, the product of the magnitude of two vectors and the cosine of the angle between them. Um, uh, the product of the magnitude of two vectors and the cosine. Which component will horizontal or perpendicular? When multiplying vectors, what type of product should be used to create a new vector? The cross product. What is a cross product? It's the product of the two vectors. The product of the two vectors multiplied by sine of the angle between them. When multiplying vectors, what type of product should be used to create a scalar? Um, when multiplying vectors, what type of product should be used to create a scalar? Um, dot product. What is the purpose of the right-hand rule? To determine the direction of the resultant vector of a cross product. The direction of the resultant vector. Okay. What is the dot product? It's the multiplication of the two quantities, or the two magnitudes, and multiplied by cosine of the angle between them. How does one use the right-hand rule? Okay, I don't actually remember this. Point your thumb in the direction of vector A, your fingers in the direction of vector B. The direction your palm is facing is the direction of vector C. I feel like I always liked it's like a circle. This is a really bad circle, but just bear with me. Um it's like something like this. I don't remember if the I, the J, the K goes like if it's I, J, K or I, J, K. I guess it doesn't matter, right? I, J, K. And like if you multiply these two, if I is multiplied by like a J, then you will yield a K. If and I don't exactly remember the details, but I feel like I always use something like that. And I feel like it was fairly useful. Low key more useful than the right hand rule sometimes. Okay, so the thumb for A, the fingers for B, and then I feel like you have to keep your hand like flat. If you don't keep your hand flat, it doesn't work. Cause I used to bend my fingers, I used to bend my fingers, but I feel like your hand has to be flat. Um, okay. What is the purpose of the right-hand rule? To determine the direction of the resultant vector of a cross product. What is distance? Distance is a scalar quantity. Um, uh, I don't know. I don't know. Like amount moved. I guess the length an object has traveled. What is displacement? Displacement, I think, counts all of the all of the distance that like I guess the amount that you have moved, the length of space that you have moved, like including like if you go backward, I think. Okay, I was wrong. I think that might be distance. I feel like which one of these cards needs to be edited. Okay, so distance is distance is both. Hold up, I'm gonna edit the card real quick. Um, uh, what is distance? Okay, it didn't really need to be edited. It just needed to be like emphasized in like the word total. Vector quantity that describes an object's change, its position in space. Okay. One, how does one use the right hand rule? So you put your thumb in the direction of A, your fingers in the direction of B, and the direction your palm is facing is the direction of the resultant vector. You put an arrow from the tail of one vector to the tip of the other vector, and if one of them is negative, then if only one of them is negative, then you flip the direction of the vector. What does multiplying a vector by a negative number do? It flips the direction and it multiplies the absolute value or the magnitude by, I guess, the magnitude of the multiplication. What is distance? Distance is a scalar quantity marking the total distance traveled to get from point A to point B. Um, like it doesn't, if you go forward and backward, it counts that, as opposed to like displacement, which only counts one direction. When multiplying vectors, this is a cross product. What component will cosine theta give you the horizontal or perpendicular? Displacement is the like it only counts the change in position to get from point A to point B. If you go backwards, it won't count it. I'm gonna give myself again because I didn't say it was a vector quantity. What is a dot product? A dot product is a product of magnitude and the cosine theta of the angle between them. What is speed? Speed is distance over time. Distance traveled over time. It is a scalar quantity. What is velocity? This is displacement over time. This is obviously a vector quantity. How does one calculate average velocity of an object? Um, Average velocity of an object. I'm like really tempted to say acceleration, but I'm not sure. Change in displacement divided by the change in time. Um, what is the purpose of the right hand rule? To figure out the direction of the cross product. What is displacement? Um, uh, so displacement is the change in but like I don't know, like the change in distance. No, it's like the length of space traveled. Um, it's a vector quantity. Uh, it only counts your like your the distance traveled to get from point A to point B. It doesn't actually count. It doesn't count if you go like backwards. How does one calculate the magnitude of a vector from its components? The Pythagorean theorem. How does one calculate the average velocity of an object? Change in displacement over change in time. How do the components add when two? They add directly, bro. Instantaneous velocity and instantaneous speed are they're they're gonna be equal if you're only traveling in one direction. Otherwise, they're not. Oh, when multiplying vectors, what type of product should be used to create a scalar? You're gonna want to use a dot product. What is acceleration? Um, Change in velocity over time. How does one calculate average acceleration? This I would assume is going to be change in velocity over change in time. What is Newton's first law? I don't remember. Any object in motion with constant velocity will remain that way until. We're gonna change this. I don't like. I don't. I remember a little bit of a different definition, so I'm just gonna put that one so that I actually like remember it. Uh, an object in motion stays in motion unless acted upon by an unbalanced external force. Oh wait, is that not this card? All right, so an object at rest will remain at rest, or an object in motion will remain in motion at a constant velocity unless acted upon by an unbalanced external force. That picture is so useless. I feel like it doesn't give enough of an explanation. What is a cross product? A cross product is it's the result or the product of multiplying the magnitudes as well as the sine of the angle between them. They're gonna be the same. So I didn't know. Describe the tail to tip method. Uh, The tail to tip method. Uh, Basically, so you're just gonna put it from. Sorry, I got a little distracted. So you're gonna put it from tail to tip. Uh, like the vectors that you're adding, you're gonna put one at the tail, the other one at the tip. If one of them is negative, then you're gonna flip the direction. We're gonna pause this for like 40 seconds. Um, what is velocity? It is uh, the displacement over time. Oh damn, I didn't say it was a vector quantity. Okay, I got myself hard. I was gonna say good, but because I got that wrong, it's a scalar quantity that describes distance traveled over time. An object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity unless acted upon by an unbalanced external force. How does one use the right hand rule? You're gonna put your thumb in the direction of the A and your fingers in the direction of B, and your palm will be facing the direction of the resultant vector. What is displacement? Displacement is just like the distance traveled to get from not the distance traveled, the length of space traveled um to get from point A to point B. It doesn't count negative direction. It's a vector quantity. What is distance? Distance is the total length of space traveled. Um, yeah, realistically. What is Newton's second law? Net wands. What is net wands second law? Um, I don't know what Newton's second law is. An object of mass m will accelerate when the vector sum of the forces results in some non-zero resultant force vector. That sounds like a very overcomplicated second law. Like there's no way that's the second law. Newton's second law. Okay, let's just read this again. Maybe if I read it a second time, it'll work. An object of mass m will accelerate when the vector sum of the forces results in some non-zero resultant force vector. Um, I mean, I guess. I guess. Which component of a vector will cosine theta give you? Horizontal, perpendicular. When multiplying vectors, what type of products we use to create a new vector? The cross product. What is the purpose of the right hand rule to determine the direction of the resultant vector in a cross product? Newton's third law. Bruh. To every force, there's an I'm gonna change the wording. With every action comes equal. You have to put some of these in your own words because it's like, what else are you supposed to do? Um, what is a dot product? It is the multiplication of the magnitudes times cosine theta of the angle between them. What is Newton's second law? It basically says like if you use a force on an object and it's unbalanced, it's gonna accelerate. So an object of mass m will accelerate when the net sum when the vector sum of the forces results in some non-zero force vector. I already said I feel like saying resultant. It's like I said it just results. So anyways, okay. We got it wrong again. What is the value of mg? No, g. 9.81 meters per second squared. But okay, I guess we can use 10. Um, what is Newton's third law? With every action comes an equal and opposite reaction. How does one relate mass and weight? Um, well, mass is mass. Weight is mass times the force times gravity, the acceleration of gravity. I would say weight is a force. Yeah. I'm low-key gonna suspend this card because I don't need to. Actually, no, I'll just give it easy. What is the formula for the magnitude of gravitational force? Did we not just do that, mg? Oh, sorry. Then the magnitude of gravitational force. I feel like I don't. Let me see if there's another card coming soon that's like. The formula for the magnitude of gravitational force. Hold up. Let me see if I want what all the letters mean. Um, one second, guys. I'm just formatting the all right, there you go. Bro, why is that all the way over there, bro? Did I fix it? Yeah. Okay. We're actually gonna simplify this a little bit more. 6.7. Maybe we should just round it up to 7, bro. Just say 7. But I don't know. Maybe I'll make that decision on test day. I don't know. So, gravitational constant is 6.7 times 10 to the negative 11 Newton meters squared per kilogram squared. Those are the masses of the two objects. And okay, Newton's second law says that if you act on some object with if you act on some object and the vector sum of the forces acting on that object results in some non-zero resultant force vector, then it'll cause the object to accelerate. It's an object with mass m. That was like a very disorganized, but I think correct answer. How does one calculate the average velocity? Average displacement or change in displacement divided by change in time. What is velocity? Velocity is the um, change in change or not change. This is just displacement over time. Okay, I'm gonna add this. I'm gonna add vector or scalar. I'm still gonna give myself a good because they're equal. Formula for the magnitude is going to be g m1 m2 divided by r squared, where g is 6.7 times 10 to the negative 14th Newton meters squared divided by kg squared. 6.7 times 10 to the negative 14th. Damn, 11th. Would describe the tail to tip method. You're gonna put when adding or subtracting two vectors, you're gonna put one at the tail, one end of your resultant vector at the tail, the other one at the tip. Um, uh, Basically, you're gonna. I actually think I've been describing this wrong. So it's like you're taking one vector and you're kind of stacking them on top of one another. So if one is going horizontally and the other one is going vertically, you're gonna basically put the tail of one vector uh, onto the what's it called? Onto the tip of the other one, and then you're gonna draw the connection from tail also to tip. So it kind of works two ways. What is Newton's first law? Um, an object at rest will stay at rest, or an object in motion will stay in motion at a constant velocity, unless an unbalanced external force acts upon it. This is distance over time. What is the formula for the magnitude of g m1 m2 divided by r squared? Um, and g is going to be 6.7 times 10 to the negative 11th. 10 to the negative 11th. Newton meters squared divided by kg squared. What is displacement? Displacement is the it's like it's the distance, not the length of space, the change in position. Is That's what it is. It's a vector quantity describing the change of position. What is the normal force? The normal force is it's like the force exerted by the ground onto you. I'm giving myself a lot of cues here. Um, so contact force. What is static friction? Um, Static friction is it describes like kind of like the barrier between you moving and you not moving, like when pushing up against some surface. So it's the amount of force necessary to get two objects in contact to start moving, or one object that's in contact with another object to start moving when kind of like being dragged. The force that exists between a stationary object and the surface upon which it rests. I'm gonna check this. Yeah, I like this definition better. The force that opposes the initiation of motion between a stationary object and the surface upon which it rests. What is the third law? With every action comes an equal and opposite reaction. What is normal force? Normal force is it's a contact force that basically prevents objects from passing through one another. It's perpendicular to the plane of contact. What is the value? Uh, I guess 10 meters per second squared. The second law states that for an object with mass m, the object will accelerate when acted upon by a force whose vectors, but if acted upon by a force whose vector sum results in um, basically just by an unbalanced force, bro. Results in some non-zero. An object of mass m will accelerate when the vector sum of the forces results in some non-zero resultant force vector. What is static friction? Static friction is a force that opposes the initiation of motion, which opposes the initiation of motion between an object at rest and its surface. What is static friction? What? Didn't I just say what static friction was? What? Bro, bro. This literally was the last card. I'm literally gonna I'm gonna suspend the other card because why is it even showing up if they're gonna put a card like this in front of me? What is Newton's second law? Newton's second law is um an object with mass m will accelerate when acted upon by a force whose vector sum is by forces whose vector sum are non-zero quantities. I'm gonna give myself that. I'm gonna be honest with you. What is static friction? It's a reactive force that adjusts to oppose motion. Its possible range of values are from zero to the static static friction, uh like the constant multiplied by the normal force. I feel like I don't need up to a maximum value. Like I don't need that. Um, yeah. I'm gonna give myself hard. This is gravitational force is gonna be like G. The gravitational constant is gonna be 6.7 times 10 to the negative 11 Newton um Newton meters squared over kilogram squared. It's gonna be G m1 m2 over r squared. What is the formula for static friction? Um, it's it's gonna be for the maximum kinetic static friction is gonna be the constant, the static friction constant multiplied by the normal force coefficient of static friction. What is kinetic friction? Is it gonna do the same thing? Is it just gonna ask me like? Is it gonna ask me this and then it's gonna ask me later on for the range? No. Okay. good. It's the force of friction that acts on moving objects. Okay, I can remember. I can remember that. It's a contact force that um, basically makes sure that objects don't pass through one another. It's perpendicular to the plane of contact. What is velocity? Velocity is a vector quantity that marks that describes the displacement over time. What is the formula for kinetic friction? Wait, I actually want to see something. Hold on. Um, what is that? Okay. Making sure I wasn't about to get copyright strike or something. Um, okay. I'm gonna give myself hard because I don't know. I'm a little confused in the wording. It sounds to me like let me actually figure this out because that way I don't just like skip over it. I feel like I skip over a lot of things. So let me just figure this out. What is velocity change in displacement or displacement over time? Or just displacement over time? Because if displacement is already a number marking change in position, then why is velocity change in the change? Yeah. Okay. Yeah. So it basically just says it basically just said that I was right, that it is displacement. So I'm actually gonna go back and I'm gonna mark this as um I'll mark this as good. What is kinetic friction? Um Kinetic friction is the force that that opposes motion in an object that's already in motion for two surfaces sliding against one another. What is Newton's second law? An object with mass m will accelerate when the vector sum of its forces are non-zero. What is static friction? Static friction is a reactive force that works to oppose the initiation of motion. Uh, it like adjusts, I guess you could say. Um, so this is gonna be, it ranges from 0 to, what's it called? The coefficient of static friction multiplied by the normal force. I'm just gonna ignore that middle one, bro. I just said that. What is the formula for kinetic friction? It's the same formula, just with a different coefficient of kinetic friction instead. What are the two important differences between static friction and kinetic friction? Well, kinetic friction is, I think that's constant. So once an object is already in motion, the kinetic friction is always being applied as long as it stays in motion. Static friction is it's gonna adjust according to how much, like, according to like the normal force, I guess. Like, it resists motion, so it can be a range. Kinetic friction is one like quantity. Yeah, I feel like I know. I already knew number two, so I knew the second one. Obviously, the coefficient of static friction is always higher. It takes a lot more force to start moving something. Um, I know it sounds crazy, but I actually mentioned this like when I was setting it up. When I was setting this up before even looking at the cards, I was okay talking about this to my sister. Um, um, okay. I think it should give me. I feel like there should be another question that's asking about the static force, but maybe I'm wrong. Damn, I might be wrong. Okay, I actually want to know the independent of contact area and velocity. So I'm gonna give myself a hard, but in what direction do frictional forces act? The opposite from motion. Okay, I'm gonna give myself again, and then I'm gonna give myself good, and then I'm gonna give myself. What is air resistance? Air resistance is it's a frictional force by like collision with all of the air molecules. What is a free body diagram? It's a diagram marking all of the forces acting on an object. What is the four assumptionness kinematics equation? So I think we have V naught is equal to V final uh, minus, this is wrong. VF is equal to V naught plus AT. Um, change in X is equal to V naught I don't know, squared plus uh, a, I don't know, bro. Those are my best guesses. Well, I actually got the okay, so I got the first one right. B naught, okay. B naught T plus 1/2 AT squared. B naught T plus 1/2. Okay, so we have V is equal to V naught plus AT. Change in X is equal to V naught squared. Damn, bro, I did it again. V naught plus, damn, I did it again. I literally keep looking at it. V naught T plus 1/2, 1/2 AT squared. And then we have V squared, damn, V squared is equal to V naught squared plus 2A delta X. And then this is like this is a family favorite. Like, physics always used to love giving problems where they didn't give the time. Oh my God, they love doing that. And then we obviously have X is equal to velocity times time. Okay, let's write that. So we have, or I'm not gonna write it again, but I guess I'll say it a lot. So V is equal to V naught. I'm gonna put my hand over there. V is equal to V naught plus AT. Then we have delta X is equal to V naught T plus 1/2 AT squared. Then we have V is equal to V naught squared plus 2A delta X. And then X is equal to VT. What is the formula for the magnitude of gravitational force? Um, Formula for the magnitude of gravitational force. So G is going to be equal to 6.7 times 10 to the negative 11th Newton meter squared divided by kg squared. And the formula is going to be F is equal to G m1 m2 divided by r squared. Opposite to the accelerating force, it's a frictional force. There's going to be a frictional force that opposes, it increases as your speed increases to create a terminal velocity. What is normal force? It is a contact force that basically prevents objects from passing through one another. It's perpendicular to the plane of contact. What are the four assumptions in this? We have V is equal to V naught plus AT. V squared is equal to V naught squared plus 2a delta x. Delta x is equal to delta x is equal to v naught t plus 1/2 at squared. And then we're gonna have the last one is gonna be delta x is gonna be equal to vt. What are the two important differences between static friction and kinetic friction? So static friction is a range while kinetic friction is constant. Kinetic doesn't account for it doesn't account for velocity or for contact area. Um, and then the static friction is always higher. Yo, this is incredibly loud for me. Is it that loud for you? Yeah, probably. Okay. All right. Let me go and lower the volume over there because this is actually like incredibly loud. Okay. That should be at least majority lower, but okay. I'm gonna lower it over here too. Okay. It's like really loud. Um yeah, that's what I said. Newton's second law is basically an object is only gonna accelerate if the vector sum of the forces acting on it are non-zero. What is kinetic friction? Kinetic friction is the force that's going to oppose motion when two objects are sliding against one another. It is a obviously frictional force. Um, I think also like yeah, okay. I didn't even ask any of that. What is uniform acceleration kinematics equation? Uniform acceleration. I don't know. Uh, Hold on, let me look up. Let me look up this card. I don't actually know what like. I want to know in what situation you would use it. That's like also important. Actually, I'm just gonna memorize it because I genuinely don't know. I guess we'll figure that out when we get to the questions. To be honest with you, what is static friction? Static friction is the um yeah, it basically just opposes motion. Its range of possible values. It's a reactive force that opposes the initiation of motion. Ranges from 0 to the coefficient of static friction times the normal force. Shortcut to calculate VF for an object falling from rest. Calculate. What is this is going to be the average velocity. Average velocity multiplied by time is equal to the x. I'm gonna get myself wrong. How does one approach a projectile motion problem? Which variable links the horizontal and vertical aspects of projectile motion? I don't know. Time. What is the vertical speed when an object reaches its maximum height? Zero. Okay, I'm suspending this card because it's not necessary. But shortcut, square root of 2gh. Um, how do you calculate the component of gravity parallel to the inclined plane? Um, Parallel to the inclined plane. Um, it's gonna be mg mg sine theta. What is it's a visual diagram of all the forces acting on an object. What is uniform of average velocity times time is equal to change in x? How does one approach split it all into its components? V is equal to V naught plus AT. Square root of x is equal to V naught T plus 1/2 AT squared. V VF squared. V squared is equal to V naught squared plus 2A delta x. And delta x is equal to VT. What are time? What is uniform circular motion? Instantaneous velocity is tangent to the circular path. Centripetal force points radially inward, keeping motion circular. What is the equation to calculate centripetal force on an object? Um, I don't remember. mv squared divided by r. What is torque? Rotational force that occurs when an object is applied to a lever arm on a fulcrum of some length. We're gonna get another definition for torque because I don't even know what a fulcrum is, bro. Okay. All right. It's fulcrum is like a supporting point, like in the like one in the middle of like a seesaw. It doesn't really it doesn't help an immense amount, but I think honestly I'm just gonna leave it. Rotational force that occurs when a force is applied to a lever arm on a fulcrum of something. It's gonna be mv squared divided by r. Uniform circular motion, basically it meets the following two conditions. The instantaneous velocity is going to be tangent to the to the circular path, and the cen- the centripetal force is going to be pointing radially inward in order to keep the motion circular. Yeah, pretty much. Opposite to the accelerating force. What is air resistance? Air resistance is a frictional force from air, that basically increases as your speed increases to create a terminal velocity. You calculate torque. It's like r the rate like it's like the radius of like the lever arm creating the torque multiplied by the force applied to it, and then the sine of the angle between them. Yeah, it's a cross product. What is torque? It's a rotational force that uh damn that occurs when a force is applied to a lever arm. How does one assign directionality to torques? Um, the right hand rule. Oh, clockwise is negative. Clockwise rotation is negative. Counterclockwise is positive. Look. This is the picture that they decide to give me, where both of them are positive, bro. Yo, hold up. Positive versus negative torque signs. Um, all right. What is torque? Torque is a it's a rotational force uh that is applied that occurs when force is applied to a lever arm on a fulcrum of some length. Oh wow, that was actually right. Two important differences. So static friction is always going to be bigger. It's also static is a range. Kinetic is constant. Um, and it's independent of the surface area or the velocity. How does one approach torque problems? Um, I don't know. Identify all counterclockwise and clockwise torques, and then identify all forces. Uh, if it's clockwise, it's negative. If it's counterclockwise, it's positive. Wait, hold up. Maybe this has something to do with righty tighty and lefty loosey. Hold up. Righty tighty, right? Righty tighty. You're moving. If you move the thing, if you twist it to the right, to the right, it's negative. Um, I don't think I have it in me to make that connection, bro. I'm not gonna lie. How does one approach torque problems? Identify all the clockwise and counterclockwise torques, and then identify all forces. What is uniform circular motion? Um, it means that it's tangent to the circular path, and the centripetal force points inward, radially inward, to keep the path circular. What is the equation to calculate mv squared divided by r? If it's clockwise, it's negative. Counterclockwise is positive. Um, mg sine theta. Identify all counterclockwise and clockwise torques, and then identify all forces. Uh, Average velocity over time. I mean, time. How does one approach a projectile motion? Split it all into the components. Which variable links time? What time? Square root of 2gh. V is equal to V naught plus AT. V squared is equal to V naught squared plus 2ax. Change in x is equal to V naught t plus 1/2 AT squared. And delta x is equal to VT. What is torque? Torque is a rotational force that occurs when force is applied to a lever arm on a fulcrum of some length. How does one calculate torque? RF sine theta. How does one assign directionality to torques? If the torque generates clockwise rotation, it's going to be negative. If it generates counterclockwise rotation, it's going to be positive. You can kind of do this, right? So, oh damn, sorry. So, hold up. Okay. So if you look at the if you're going like this, right? You're going like this. Okay. I guess you can always look at it from the direction of like its start and end point are gonna be like, I guess you can't really do that. If it was going counterclockwise, if it was going counterclockwise, like it just I guess it's too relative. I was gonna say that the arrow is it's pointing more positive, but it's not, because obviously it spends an equal amount of time trying to get into the negative as it does getting into the positive. Um, but I think I'm still probably gonna remember it like this. This this one is trying to turn negative. This is gonna be that's gonna be the clockwise. Clockwise is trying to turn negative. This is not even clockwise, bro. Am I bugging? Oh yeah, it is. Oops. Okay, I did get it right though. How does one approach torque problems? Find all of the counterclockwise and clockwise torques, and then identify all the forces. What is uniform circular motion? Basically, like the instantaneous velocity is going to be tangential to the circular path, and then the centripetal force is going to be radially inward in order to keep like motion circular. What is torque? Rotational force that occurs when force is applied to a lever arm on a fulcrum of some length. What is the equation to calculate mv squared divided by r? Well, it ended right as we were finishing. Okay, so it thinks that I need two more cards. Why does it think that? Oh, it thinks I need two more cards because I suspended two cards. Well, it's okay. So we have now completed 15% of the deck. 835 cards completed. Wow. Isn't that phenomenal, guys? Isn't that phenomenal? Um, all right. So now we have to do our Jack Weston, and then we can call it a day. We get this over here. Screen capture. Um, Google Chrome. Uh, Jack Weston. All right. All right. So, need to refresh from last time. All right. Let's get this. Let's see. Okay. Okay. It was between low key. Low key, it was between all these. So let me check. Price does not indicate that architects should pay attention to what kinds of home products are selling well. Mentions watching ads, but only to pay attention to the background. Yeah, that's true. Does not make a recommendation. It suggests that architects look outside for ideas. Wait, what? Watching television shows on architecture. The point that the author makes about how little choice. Okay, I feel like this one should be right. Yeah. Damn, that was hard. Give me 1 second, guys. Okay. Let's see. All right. Yeah. Okay. Because I'm only gonna look at. I only feel like it's worth it to look at the questions that are. It's only worth it to look at the questions that I was actually struggling with. Um. All right. Well. So thank you everyone for watching. I hope you guys have a great night, evening, afternoon, morning, or anything else, any other part of the day, any other part of the morning, you know? Hope you have a great rest of your night